Good morning, Silicon Valley. Good morning, good afternoon, good evening if you're watching this next general session out there on the World Wide Web via SYS-CON TV. Our next general session here, day 3 of 13th Cloud Computing Expo, is Gary Ballabio, one of our favorite speakers from one of our favorite companies, Akamai, product line director, is going to take us through and get this, because he says it's, with apologies to Hunter S. Thompson, fear and loathing in the cloud. What on earth is he going to talk about? Let's give it up, please, for Gary Ballabio.
Thank you, sir. All righty, thank you, Jeremy, for the introduction. My name is Gary Ballabio. I'm a product line director at Akamai Technologies. I cover Akamai's enterprise cloud solutions, and basically what that means is I'm responsible for providing solutions for enterprises that are adopting cloud capabilities. So from a high level, what we're going to talk about today is, one, talk a little bit about the trends happening from a cloud adoption standpoint. Talk about some of the challenges that we're seeing from some of our customers in the adoption of those services, some of the solutions related to that, and also talk a little bit about how you can integrate big data with a solution like Akamai. So from a high level, this is a very exciting time. Gartner has provided this data. This is recent data from Gartner's Q3 State of the Public Cloud report. And cloud adoption, really no surprise, it's really taking off. More and more applications are moving into public cloud environments. More companies are leveraging public cloud environments for elements beyond just CRM, beyond just HR. There's more and more different types of applications moving to the public cloud. More mission-critical applications as well as business-critical applications. It really isn't just a test bed anymore, where companies are leveraging it to test out new features in a very fast and agile manner. Of course, that is still happening, but now we're seeing more and more companies take a look at it from a very serious standpoint, looking at how can I leverage this for more production types of applications. So that's really exciting. It's exciting to see the companies getting the benefits of the agility, of the cost savings, and the complexity reduction of utilizing cloud services. At the same time, hybrid cloud is also becoming more and more of a consideration. Definitely seeing that become more and more of a standard in running in private cloud and then moving into public cloud when demand is really high. And that's something that other researchers are saying is going to start to really increase over the next 5 years and even be the dominant in the next 5 years. And at the same time, what's really driving a lot of this adoption is really around devices. So there's many different types of mobile devices. You have emerging markets. You have BYOD initiatives in corporations. And a lot of that is also driving the need for public cloud adoption as well. And then at the same time, big data. One of the most important, I think, one of the most important initiatives right now. And that's really changing how businesses work or interact with their customers, with their end users. And it's also going to continue to evolve. And leveraging the cloud is also going to be a part of that change. Forrester released a report in the beginning of this year. They said that 41% of all companies globally are going to be adopting infrastructure as a service in the next couple of years. And that's up from 29% of all companies in 2012. They also said that 32% of all companies in the world are going to adopt platform as a service in the next couple of years, which is up from 19% in 2012. And they also said that 60% of all companies in the world are going to be adopting software as a service in the next couple of years, up from 45% in 2012. Again, these are really exciting statistics, and it's really exciting to see the adoption really start to increase for the cloud. Now, when companies adopt cloud services, and especially if you're working within an infrastructure as a service provider, you're looking at optimizing the application within those 4 walls. So how do I make sure that the data is accessed quickly? How do I make sure that the response is as fast as possible outside of to the actual end user getting out of the data center? What they also need to consider, and there are many different companies that are providing those types type of capabilities for you as well, and helping you optimize those environments. What they also need to keep in mind is, how do I optimize those applications for the different types of end users that are accessing those applications? Where are they coming from? What type of connection are they on? What type of device are they using? What operating system is on that device? What browser is on that device? All of these elements also need to be taken into account to also provide the best possible experience for those end users. And then the last element really comes down to the internet, that little thing that is connecting your end users with your applications. Optimizing that transport layer is also critical to providing the best experience to end users. And that's really where Akamai comes into play, is optimizing that internet that layer between the end users and the infrastructure. So a little bit about Akamai, what we do. Akamai provides an optimized delivery from a centralized environment. So if you're running an application out of, say, AWS East and you have global end users, Akamai can help make that an efficient delivery to those end users. You can also standardize security policies regardless of where the cloud provider is, where the application is actually hosted, or where those end users are. We provide a distributed application firewall, so you can standardize your security rules really no matter where the application is hosted. You can also optimize the experience based on the end user's situation. So when I mentioned earlier about the type of browser, the type of device, the type of connection that they're on, all this can be taken into account to optimize that content for that end user. Also around availability, ensuring that every single user request is responded to in an efficient period of time. And then lastly is from a real-time data feed standpoint, integrating data or activity about the application from that Akamai is serving back to your analytics environment, into your Cloudera environment, into your Splunk environment for analysis. So I'm going to take a step back and talk a little bit about some of the challenges faced on the internet for anybody who's running an application through it. So from a high level, the internet is a very simple thing, especially for your ordinary consumer who is accessing any sort of website. I open up my web browser, I type in www.foo.com, I hit enter, and voila, the page loads. But for a lot of you out there, you know that the internet is actually way more complicated than that. The internet is a network of networks that have to work together in an efficient manner to basically be able to transfer that data from the cloud environment down to the end user. And there are laws governing the internet, like BGP, Border Gateway Protocol, that really have to work in order to achieve sending that data from the cloud infrastructure to the end user. But components like BGP are not geared with performance in mind. They're geared more towards cost in mind. Right? And there's also challenges around peering as well. In times of heavy load on the internet, that's when these common routes tend to get congested. And it's really difficult for anybody who's serving an application from a cloud environment to deal with those sorts of problems. So, and the cloud also introduces some new challenges as well. So take an example of an application running internally or running on your private LAN. It's fast. You don't have to worry about security concerns because it's in a private network. Then if you move that application to a public cloud environment, now you're introducing distance, which creates latency. And you're also now exposing that application to the public. So therefore, now you need to start thinking about security, of protecting those assets, of that application and the assets when it's on the public cloud environment. At the same time, you also lose some of the visibility, or it become less efficient to get information about what is happening with that application. Getting an understanding of the resource and getting a real-time view to be able to respond to those conditions can be a little bit more challenging. So in terms of this talk, I'm going to break it up into 4 different areas. 1, talking about performance and how you can overcome some of the challenges related to performance when running an application through the internet. 2, talk a little bit about availability. and how a network like Akamai can help you overcome challenges with availability. We'll talk about mobility. Obviously, mobile is becoming so important for a lot of us out there, and how, again, you can leverage services to improve users' experiences on mobile devices, and also how you can improve security and as well as the visibility of those applications running out in public cloud environments. We'll start off with performance. So for those of you who are unaware of who Akamai is, Akamai runs a globally distributed network of servers. We have over 120,000 servers in about 1,100 networks. And that means we deploy our servers into ISPs as well as into the core backbone networks. So our goal is to be as close to end users and as close to the actual infrastructure as possible. We're very trusted. We serve all the top 60 e-commerce sites, top 30 media and entertainment sites, as well as 9 of the top 10 banks. And on a daily basis, we serve upwards of 30% of the world's internet traffic. Upwards of 12 terabits per second, 27 million hits per second is what we support on our platform today. So going back to some of the challenges related to cloud adoption, so I go back to moving the application to the public cloud environments, we address that leveraging our global network of servers. So we deploy servers as close to the end users as possible, and we deploy servers as close to the origin infrastructure as possible. And from there, we establish, we ensure that the connection that the end user establishes with Akamai is as efficient as possible. They're connected to a close server, and then from there, we can optimize different elements. So number one, we can leverage our expansive network and the information we have about internet conditions to optimize the route that the data takes to transfer from the origin location down to the end user. Akamai is connected to the internet via public BGP routes. So taking a local example, if you were to drive from San Jose to San Francisco, there's really 2 main routes that you can take. You can take 101 or you can take 280. Most of the generic map software on the internet will tell you to take 101, but that's where a lot of the congestion is, that's where a lot of the problems are. Most locals know they take 280. That tends to be least congested and a better route to go. You can think of Akamai the same way on the internet. We're able to find the public routes that are least congested and that are the best path to move data from point A to point B. That's how we optimize routing through the internet. Next thing is we optimize the connections. So TCP is a protocol that was designed in the 70s, and it wasn't really designed with the high bandwidth connections that are in place today, and also not designed to live up to the expectations that users have today when downloading something from the internet or downloading a web page on the internet. TCP is a conservative protocol, and we can overcome some of the challenges of connection time. And then once the connection is established, we can move more data through that connection than standard TCP would allow. That allows us to move more data through that optimized route as quickly as possible. And the last thing is just the movement of dynamic content. So those of you who are familiar with Akamai tend to think of Akamai as static caching, CDN. That's our history. That's where we came from. But we also, on top of that, are able to move dynamic content through the internet, leveraging these capabilities, optimizing the route, optimizing the TCP connection, and also predicting what elements are going to be needed by that end user, and being able to prefetch them and have them loaded on our servers even before they request them. These are all things that we do to optimize the delivery of those applications. Here are some examples of the Akamai at work, essentially. We have some Gomez tests here for an application hosted on AWS East. The blue line represents the Akamai response time, and the yellow line represents these global agents' response time going direct to that environment. And this is no reflection on AWS. It's simply a matter of the challenges that the internet presents itself and the ways that we can overcome those challenges leveraging our network. In the histogram below, you can see Akamai is able to shift a lot of the user response times over to the left. That graph represents how many transactions by those test agents completed in 3 to 4 seconds, or 5 to 6 seconds, 7 to 8 seconds. And the blue lines represent the number of transactions actually completed in those periods of time. So you can see there is a dramatic shift over to the left. So you have fewer end users kicking and screaming that the response times are just not good enough. So I will talk about availability. So one of the challenges with availability is end users can make a request for content, but what happens if that environment or that route to that environment goes down? This is a very real problem, and it can happen at any moment, especially as you have more end users, even more distributed on the internet. If Akamai is in the middle, we can actually detect that in real time and be able to say, okay, let's now fail over to the secondary location that has that data or is running that application. Oh, what if that environment happens to be down? Then we can fail over to a tertiary location, and so on. These are sophisticated rules that we can establish based on session information or just based on generic load balancing. It may be that you want us to only serve 50% of the traffic out of one location, 30% from another, and then 20% out of another. We can also do that as well. That's something that we call cloud balancing. The ability to shift traffic, the ability to shift from one environment to another dynamically based on real-time conditions. What you can also do, what we have a lot of our customers doing with us today, is the ability to smoothly burst from a private cloud environment to a public cloud environment. So take an example of www.example.com. Normally, that transaction should be served from a private cloud environment. And that works really well in times of normal conditions. But then, if it's peak time, that's when we want to shift some of that demand or some of those requests over to a public cloud environment. And that can be done by leveraging techniques like a global traffic management system, which is a DNS-based service. The downside to that is that it could take a couple of minutes in order to shift the traffic over because it's DNS-based, there's time to live values you need to overcome, and of course some of those DNS servers are going to be caching the results of the response. With cloud balancing, there's a layer 7 technique that we can leverage in order to move traffic from the private cloud environment to the public cloud environment. And what I mean by that is, let's take an example of I have a store that I'm running. And that store, I have let's say just two main directories, the catalog directory and the checkout directory. So let's say in times of peak period, I want to ensure that the checkout traffic is always served out of my private cloud environment because that is the environment that is PCI compliant. But then the catalog traffic, that tends to be the heavy images. That tends to be the one that is consuming more of the resources in my private cloud environment. I want to move those over to the public cloud. And that's the sophisticated type of cloud bursting that we're able to provide. Taking layer 7 information about the directory, information about cookie information or session information, anything coming in from the request from the end user, and being able to force that to be pulled from a separate location. So we'll talk about mobility. Mobile is obviously an increasing concern for a lot of our customers. And when thinking about mobile, there's a lot of the customers that I deal with don't necessarily think about the challenge of the type of connection that the user has to their content. So there's a very big difference in latency that you receive when you're connecting from over 3G versus 4G versus Wi-Fi or cable. And it's very important to keep in mind in order to ensure that you're optimizing the experience for the end user. At the same time, there's also differences in the devices. So traditionally, a lot of companies who develop applications for their employees, they're developing with a certain use case in mind. They're developed. They know the laptops. They know the environments that these applications are going to be run on, and therefore they can build towards those requirements. But now if you enter in mobile, you enter in BYOD, now you're getting into many different types of devices that are coming in with different types of capabilities and different types of abilities. So there's different CPU, there's different memory restrictions. Some support JavaScript, some don't. I mean, there's all sorts of issues that now come into play. And these aspects should be taken into account in order to optimize the experience for those end users. And you can leverage techniques like front-end optimization in order to address some of those challenges. Front-end optimizations is an industry technique. These were techniques developed by Steve Souders. He's a performance guru based from Google. And he developed a set of rules that allow you to optimize the content for the end user's device, for their browser, for their operating system specifically. And you can leverage these techniques in order to ensure that the content itself renders as quickly as possible on that device. We incorporate these rules on our service as well in order to ensure that we're optimizing not only the network layer, but we're also optimizing the rendering of the content on that end user's device. So I'll quickly talk about security and visibility. So from a high level, when you're using a distributed network like Akamai and you're delivering an application through a network like Akamai, you created a natural defense mechanism because of the sheer distribution of the platform. And so user requests go through these servers, and it makes it harder for somebody to try to send a SYN flood attack to your application. It's now fronted by hundreds of thousands of servers by Akamai, just as one example. What we also have is the ability to distribute web application firewall rules to our servers. We have the mod security rule set that can be leveraged and can detect things like cross-site scripting or SQL injection types of attacks. So going beyond just your standard denial of service attack and looking at the application layer and looking at the security of the application itself to now protect the data. Now, what's more is you can leverage those rules on the platform no matter where the cloud application lives. It can be on your private cloud environment. It could be on a public cloud environment or any public cloud environment for that matter. So now you can standardize the rule set no matter where those applications are actually being run from. Then we also have this element of real-time data feeds. So with the promotion of big data, it's very important to get the data as quickly as possible so that you can integrate it with your business operations and do something about that data. When you move an application to a cloud environment, it can be a little more difficult to get that real-time feed of the activity of that application. Leveraging our servers, what we can do is provide a data feed for any event as it happens while we're delivering it. So it could be a 200 response code, or it could be a 500 response code, or some sort of 404, or any sort of events that trigger us to send information to your analytics environments. We've integrated this technique with some application performance monitoring vendors and also log analysis vendors as well. It's a JSON format, so it's easily instrumented to be analyzed by these types of services. Two of the examples that we have are one, Sumo Logic. Sumo Logic is a SaaS provider that basically does big data analysis in the cloud. We've integrated our technology with them. They are a partner of ours. And the graph that I'm showing there is from their dashboard, and you can see some of the responses going from the different cloud environments that this application is being run out of. BMC Software, they're also another partner of ours leveraging this data feed from us, and they're integrating it with their end user experience monitoring service. And that actually provides APM as a service, or application performance monitoring, essentially as a service. It used to be that when you wanted to monitor your application, if you wanted to get a very deep view into the data, you needed to tap a network line or span a network port to get and collect that data. Now that is very hard to do when you move an application to a public cloud environment. How are you going to span the port or tap the network line to get that data? So we've integrated with BMC in order to provide that information completely as a service. So we send BMC information that we see about that application on the internet, and then they leverage their reports and their dashboards to expose the same information you would have gotten if you were hosting that application yourself. So that's a really new technique and a really exciting feature, something that we're working on with BMC. But there's also this element of, hey, my applications don't just live in the public cloud. I also have a lot of applications on the private cloud. What can you do for me there? So this is where we recently announced a partnership with Cisco, where our Akamai is going to be working with Cisco to address the challenges, not only just in the public internet, but also on private lines as well. So imagine a situation where you wanted to, say, optimize your private line. Well, that would mean that you would have to install boxes of Akamai's inside the private network in order to optimize the transactions between the remote office and the headquarter office. In working with Cisco, we're actually going to embed Akamai's software into Cisco's routers. And so if you have an ASR router, it's automatically going to be updated with Akamai software next year. So that way you get the distribution of Akamai in your private network and then start to get the same benefits of acceleration, whether it's happening over a private line or over the public internet. So from a high level, the cloud is really exciting. And all the benefits of cloud are also really exciting. And it's really nice to see our customers getting the benefit of the reduction in complexity and the reduction in costs. But the cloud itself just isn't enough. You need to combine it with other services in order to get the full benefit of intelligent delivery through the internet. Solving that problem of the actual element that is connecting your end users with your application. And that's what Akamai does. We power what we like to call the intelligent cloud. So in summary, these are really exciting times. I don't think I could say it enough. The cloud challenges are also internet-based and also need to be thought about when running any application from the public cloud. Our solutions are complementary. That's complementary with an E. And it can also save costs and improve productivity. So with that, I'd like to thank you. And if you're interested to see a real-time view into the activity happening on the internet, you can download Akamai's application from the iTunes Store, and we give you a real-time view into some of the data, what we're serving right now. Thank you.
Thank you. Gary Ballabio. I always love those data points. I was jotting them down. Any questions for Gary before we release you to the expo floor? Oh, right there. Perfect.
Yeah, I just want to know if, do you anticipate any slowdown in cloud computing due to the NSA revelations? I mean, basically, it appears that U.S. companies may be affected, with the competition in Europe,
Mm-hmm. Right. So, I mean, what we do is we optimize the transaction flow from any cloud environment to end users. So really, it's up to the application owners to put their applications in an environment where they want to run it from. And so we're outside of that decision. That's not a decision that we influence or anything. We're just optimizing the internet channel between the end user and the cloud application, no matter where it is.
Another question, please. But you don't look like you're getting up to go to the expo floor, so what is it that you don't want to ask Gary? Well, let's say thank you instead, because he's the only person who uses exciting more than I do. Gary Ballabio, Akamai, thank you very, very much.